Hi guys, welcome to Backend Engineering School. And it's been a long time since I uploaded my last video, but now I'm back. I'm back in the action, so I'll keep on uploading videos now, same as I used to do some time back. So as part of this video, we will be discussing the microservices. So what I think of is to start a series of microservice where we will first start with the introduction part, the fundamentals, then we will understand in depth of it, right? And then we will see how that fits into the deployment aspect, the Kubernetes, the Docker and all that. Then we will also understand in the end the CI/CD and the other part, right? So this is just a beginning. So let's quickly understand the conceptual part, that what are microservices, and then use the problem solution approach to understand that what is the problem we have and the problem that is being solved by using or adopting the microservices, right? So this is what we will be discussing around this lecture. So let's quickly begin. So before getting into the microservices, right, we first need to understand that how a business looks like, because today whatever you do, everything revolves around a business, right? So for example, you working for an IT consulting firm, that IT consulting firm must be working for some other core domain function company, right? Maybe in the healthcare, maybe real estate, your media, retail, airline, whatsoever. The point is, your core domain company is doing operational in a business domain. Now today, if you see, today is the economy of competition, right? There is a tough competition in the market. When somebody comes with one technology, other organization also tries to adapt the same technology or try to get a better at it, right? So point is, the world is moving so faster, in for that matter the businesses are moving so faster, right? Now if businesses are moving so faster and all the other businesses that are dependent on the core business are also supposed to be move faster. Why? Because there are requirements coming in, continuous requirements. We will have to develop and put something, we will have to implement whatever the new requirement is coming in. We are supposed to adapt those changes faster, right? And then we are also supposed to deploy, ship those changes faster, those features, right, to the end users. And then very soon eventually we'll get the feedback from the end users, from the stakeholders, etc. And then you again plan something, right, to fix that feedback or the scope of improvement whatsoever. Then you again implement it, then you ship it, then you again get a feedback. So if you see, on a 10,000 feet level, this requirement never ends. It's endless going on, right? This iteration, it always keeps on going, it never ends. It's an endless iteration. The point is, now if we adopt a method which is not aligned towards this kind of business view, we will again fall into the problems where we won't be able to ship features faster in the market, and hence there will be business loss, there will be revenue loss, there could be different kind of the losses from different aspects to a business organization, right? So this is where we, as an IT company, we are supposed to adapt something that make us to align more towards this kind of business view, this business view that I'm talking about, right? So you can continuously keep on planning, continuously you can implement, continuously you can ship, and then continuously you'll keep on getting the feedbacks, right? So this is where the things like microservices, CI/CD, all these things comes in. But now we still don't know how this microservices relates to it. Now let's quickly jump in and then understand, right? So if you take an example of, let's say, you have a solution, let's say software application, right? So let's say your Java application, right? So this Java application, let's take an example that you are giving your services to a retail company. So that retail company is sending or selling the consumer goods, etc. Now this app takes care of the multiple e-commerce aspects, right? Multiple e-commerce aspects. So you have an online application, right? Online retail app, kind of. You go to offline market and then you also have a online application, and then this application has everything in it. Let's say you have shipping features in it, right? You have order features in it, you also have the product features in it, right? You also have, let's say, the invoicing in it, correct? And then you also have the user info in it. So when I say all these features, that means the code logic inside this Java application has everything, all the business logic that is specific to shipping, that is specific to order, product, invoicing, user app information. So whatever call comes in, all those call comes into this application. All right. So now if you look from the other perspective, and then looks from the other perspective, from the deployment perspective, so you see that on an average, if I say this is a big Java application, right, this Java application has all the code. So this is from the code perspective. Look through the deployment perspective, so you'll see that it needs 4 CPUs to run this application, and also it needs 512 MB, or let's say not MB, let's take in the GB, so let's say 250 GB memory to run this application. So that's the configuration you need in order to run this application, to put this online, in order to run, let's say, 5,000 users per month, right? 5,000 users per month. So that's the user base you have. That's the user base. When I say user base, means the targeted audience that you are expecting in a particular environment. Let's say you have deployed your services into production, so your services are live now, and then end users have started using it. Now, what is the user base? When I say that, what is the targeted user you are thinking that maybe in a month or so will start using your application, right? So that this is from a few multiple aspects, right? So this is from the deployment perspective, this is from the user base perspective. Now think about a use case. Now let's go one by one, right? From few of the use cases we will understand. Now you have this big application. Now think about from, let's say, your implementation perspective, right? Think about from the implementation perspective. When I say implementation perspective, that means code change perspective. Okay, what do I mean by code change perspective? What I mean is, so let's say you have a user, right? You have a team of, let's say 8 developers, right? Now, since we talked about developers, let's say there is a new developer joined the team, right? So your team became 9 devs team, right? Now, new developer, if I ask a new developer to make changes in this application, this big application, will he or she able to make the change so easily? No, answer is no, right? Because you have this much bigger application. Your code is so strongly coupled. Only the guys who has been working on these applications, right, are comfortable enough to make changes in this application, because they understand that if a particular code is there, if they have created a class, what is the reason behind the way they have created this class, right? So it's not easy to make this 9th developer, the new one, to make the code changes unless he gets a correct KT or takes some time, right, to get the hands-on into the code application, etc. Second thing, from the code implementation perspective, that it's not very easy, because you have very strongly coupled code, right? Maybe when you adding a new functionality, you may have to change or alter the existing functionality. So the point is, the code changes, doing implementation in the existing code base, it's not so easy because you have a big application. All right, now think about the QA perspective. If you think from the QA perspective, so you see it's a big application. As I said that while doing the implementation, you don't know that if you are adding a new functionality, maybe you will have to alter the existing functionality, may or may not, that depends on the use case, right? But if you are building this very strongly coupled application, big monolithic application, then the chances of changing the existing functionality are higher if the application is not designed well, right, so far. So the another problem is QA. If there are changes in the existing functionality, then QA has to also make sure that if you have added few changes in the user information, then QA also has to ensure that if the invoicing and the order is very much related to the user information, then the QA team also needs to perform the regression on all these things. The point is, the QA effort on an average, right? I'm not saying that only the regression they will perform, maybe some kind of test, but the point is the overall QA effort and time will get increased, right? So that's the eventual point. Now think from the another perspective, right? Now think from the deployment perspective, right? Now think from deployment perspective. When you are deploying this bigger application, right, you have to perform, you need a big production window, right? Because you deploying a big application, right? And then once you deploy that, you will have to make sure that each of the features of these services should be running. So you need to perform the sanity testing, the basic functional testing of each of the features. You also have to ensure, because it's a big application, right? And then it might have some kind of other dependencies as well. So you manually have to take care all those dependencies as well, right? So your deployment effort will also get increased, right? Now think about from the scalability perspective, right? Now think about from the scalability perspective. Now scalability perspective, when I say, so you have this application, right? So we have been using this application, this Java application of the retail to maintain the online retail. Now but also understand that whatever I'm talking about, right, this big shot one application, single application, this is also known as the monolithic application, right? So do you think if there are any other issues as well along with the monolithic application, just mention it in the comments, right? So now let's moving on, and then think about the scalability perspective, which is very important to understand. Right now let's quickly understand the from the scalability perspective. So as I said that there is one application which serves this one application, let's say this Java application, right? And then this Java application serve, let's say, 5,000 users per month, correct? And then this has 4 CPU and then 200 GB memory. Now if I want to serve, let's say my total target is to serve 20,000 users per month, right? Then how many number of services instance I would need to run, right, to execute at any time in my production environment, right? So I would need another instance, and then I would need another instance, right? So I'll say this instance. Okay, so this will also be the same application, right? So this is instance 1, this is JA instance 2, this is JA instance 3. JA means Java application, and then JA instance 4, right? So this is also 4 CPU, 200 GB. This is also 4 CPU, 200 GB, 4 CPU, 200 GB. So you see, then this will be able to serve the 20,000 users per month, let's say. Now point is, if you see that in your retail application, you may not want to scale this order service, because let's say if you are using Amazon or Flipkart or any kind of e-commerce application, the number of read calls are higher, kind of, right? Because e-commerce systems are more of a read heavy systems, because what you do is you keep on scrolling. If you just look through the user experience perspective, the user behavior perspective, I'm not saying that I'm taking very vague example, I know, but just take an example from the user behavior perspective. So at least from this user behavior perspective, this application is kind of a read heavy. So in this read heavy system, you may not want to, maybe you don't need to, scale the order feature, because you won't get a lot of orders, right? So there won't be a lot of write operations for the order, right? And then same, if there are not many orders, then you won't have to scale the shipping, because shipping is something directly depends on the number of orders you are getting. However, or the same applies to the invoicing as well. However, you do need product to scale and the user info to scale, right? So what everything that you want to scale, you want to scale the user info, and you also want to scale the product, because this is because of the fact that it's a read heavy system, right? And then you don't want to scale what you don't want to scale. You don't want to scale the order, you don't want to scale the shipping, and then you don't want to scale the invoice, right? Because if somebody places an order, then only you get the invoice and everything done, then only the shipping gets initiated. However, when user logs in into the application and performs a lot of browsing through the products, then these are the main features that are being utilized as part of your business logic, right? Now, as per this design of your application, where you have everything into one single application, right? When you have a monolithic kind of application and you have everything right here, is it good to say that if when you scaling one application to 4 instances, right? And then this one application has everything. This has order, this has shipping, this has invoicing, this has product, and this has user, right? And then same applies to here as well, same applies to here as well. So when I say when you are scaling, when you are increasing the number of instances, right? So can I say that, is that okay? You are also scaling the user info, the order, shipping, and invoices, and even the fact that I don't want to scale these things. I only want to scale these things. Then why would I waste my money on scaling these things, right? So in this scaling, this is kind of a horizontal scaling, right? Because what you're doing is you're scaling horizontally, right? So it's a horizontal scaling. We will cover the discussion of the scaling, horizontal scaling, and the vertical scaling. We'll cover that part in a separate video. All right. If you want me to create a new video on the scaling and the horizontal versus vertical scaling, just do comment in the comment section. I'll create one video. So now the point is, I don't want to scale these features. I only want to scale these features, but still I'm paying for a lot of money. So let's say if you have 4 CPUs, right? And then you have 4 instances. So how many CPUs? You are paying for 16 CPUs, right? And then if one instance is taking 20 GB, you have 4, then you are paying for 800 GB, correct? So now this is all happening because of my bad design, because one application has everything in it, right? Now this is where the concept of microservices comes in, correct? And then it saves you from wasting a lot of money. Although we cannot say that microservices comes with each benefit, right? There are only the benefits you have along with the microservices. No, that's not the case. It always depends, right? There are trade-offs, right? When you get something, you always lose something. So that depends on that what you get something, is it aligning with your requirement or not, right? So based on your requirement, you go and select a specific path, right? So now let's quickly talk about this solution. So you have product here, you also have invoice here, you have shipping here, you have product here, and then you also have your user here. So now what the easy solution to do is, you simply, to this monolithic application, you divide it into small applications. So what you do is you take out the product service into a separate service, right? And then you take out the invoice service into a separate service, and then you also take out the user info service into a separate service. Then you take out order service as a separate service, and then you also take out the shipping service as the different service, right? So you have this domain, right? And then which is more of a user domain. You can call it as any domain, right? So you can call it any domain, that hardly matters. User and product domain, and then you will say that this is a purchase domain. Domain is nothing, it's a logical segregation where you have put in your services separately, right? So what you're doing is, because of the fact that you don't want a lot of services, you don't want multiple instances of these services, so you only assign, let's say, the 1 CPU to your order service, and then 0.5 to your shipping, and 0.5 to your the invoice servicing, right? Then again, it's a vague example, right? It's not very realistic. I'm just making you to understand. I'm taking these examples. And then because we want this product service to be faster, so I'm assigning this 1 CPU to this guy, 1 CPU to this guy, right? Now what I want is, I want to scale the system. Now my system is read heavy. We already understood that, right? Because of this fact, we understood that our system is read heavy. Then I don't want to scale this because it's a purchase domain. It only happens, it's a write domain, let's say, and then it's a read domain, right? Then what I want is I only want to scale product and user. So what I'll do, I will only scale the product and user. So I'll say a product and user, and then I'll say a product and user, and then I'll say a product and user, right? So this will be 2 CPU, this will be 2 CPU, this will be 2 CPU, and then one instance for invoice, one instance for, and then shipping, one instance for order, right? So this is total 2 CPUs, right? And then 2 2 2, it's 8, and then 8 and 10, sorry, it's total, right, 8 CPUs, right? So what you're doing is you paying cost for 8 CPUs right here, right? And then here you were paying this, here you were paying for 16 CPUs, right? So did you understand how did you reduce the cost by migrating to the microservices? And then the tuning the all the resources, when I say the resources, that means the infrastructure resources, services correctly, right? That it's a collective exercise. It's not very easy to just creating microservices directly. Adapting microservices takes a lot of time and expertise, right? There are a lot of trade-offs involved. But on an average, you can see that the overall cost has been decreased, right? Overall cost has been decreased. So that's the benefit that you get when you migrate to the microservice. So microservices is nothing, right? Did you see that microservices is nothing? It's a small application. It's just a small application. You have broken down a big application into the small application, right? That's what we did. If you saw that, that's what we did here, right? We broken down this monolithic application to these microservices, right? And you call it break. You have broken down it to microservices, right? So microservices are smaller services independent of each other, can be implemented in any of the language, hardly matters, and then you can scale it well, right? If you see, the point is you can scale horizontally in the monolithic applications as well. The point is monolithic application doesn't scale well, right? So you now if somebody asks you a question, can't I scale horizontally the monolithic application? The answer is yes, always you can scale. The problem is it won't scale well, and you will end up wasting a lot of money on the resources, right? And then where on the other hand microservices scales very well, right? And where you end up again, you don't have to waste a lot of money in deploying all these services, right? So scaling is very important aspect right here, right? So now, as I said that when you break a big application into small application, this is where the microservices come in, because these are smaller services, right? And then as I said, I already discussed about these problems, right? The scalability issues, the deployment issues, and the tight coupling issues, the slow business adoption. When I say the slow business adoption, that means that the business changes cannot be adopted so easily, right? Because you have a big application. You cannot make changes easily. You will need some time to make changes in it, right? The same thing in the rigid technology stack. How if your application, one single application has everything into it, and then that is implemented in Java, then even if you are adding one more functionality, that has to be in Java. But that's not the point with the microservices, right? Microservice, one service is deployed in Python, another you can implement in Java, that hardly matters. Another one you can implement in Rust, that depends, right? And then again, as I said, that there will be some project management challenges and the single point of failure. For example, as I said, if you have a one single application and then you have a global teams, right? The team has been distributed globally across multiple countries, then it's not very easy to channelize and maintain a strong communication channel, right? What changes going into and what change you are deploying in, right? So all these problems come up, and then to fix all this problem, I already explained you, right, that microservices comes with a lot of features, right? Everything, all the problems that you had earlier with the monolithic application was solved with the microservices. All right. So now this was the basic concept of your microservices, and then why do you even need that? Now let's quickly discuss one question that could come up is always following microservices a good idea? Answer is no, right? You should not follow microservices till the time you genuinely need it. So let's take an example of a startup. So startup, it's trying to create a POC and trying to take that market into the public, where it can understand, the startup can understand if the product fits to the requirement of the market, everything or not, right? Then will startup should follow the microservices? The answer is no, right? Because why? The basic agenda of startup is to take this application, whatever the logic, the business they are trying to implement, to the market, right? So we want the faster market. It hardly matters if your application is scalable, reliable, etc., right? Because creating the proof of concept is only the important agenda here. So you should always create the monolithic application. Now let's say understand that if this startup has become so bigger and then has received a lot of funding, right, and has been into market for, let's say, 5 years from now, then now startup has seen the product, the platform of this startup has seen a lot of scalability issues and other design issues. Then should this market then should this startup, the company, should migrate to microservices? Answer is yes. If you have started seeing issues and you have enough budget to spend on the migration to the microservices, adopting a cloud provider or something, always yes, you can go for it. But if you are the startup, small business, medium business, and then you don't have a specific requirement with the microservices, there is no point to create microservices, right? That also increases your maintenance. You also need resources. There are other the demerits of microservices as well, right? So it's not one solution fits all everywhere. That's not the solution that works, right? So that always varies on what requirement do you have. Do you also agree if with my statement? Say yes to the comment, and then if there is any other video or something, that because I've started again, then please comment that into the comment section. I'll probably try to create a new video on it, right? So I hope that you like this video, and I hope that you are able to understand the concept of microservices. So probably I'll meet you in the next lecture with some other topic. Thank you guys.